Hi guys, let us discuss about gravitation part 2 now quickly. Yesterday we discussed gravitation part 1. Now in gravitation part 2 the remaining topics let us discuss. We are discussing about gravitation, all the topics regarding NEET entrance point of view, okay. Now latitude factor. In the last class we discussed height factor as well as depth factor. Now this class latitude factor. This is equator, this is pole, this is a point. This point is making an angle phi with x-axis or equator, that is called latitude. Angle made by the line joining the point and the center of gravity of the earth with the equator represents latitude. Now at equator latitude is 0 degrees. Angle, if this line is on equator, angle is 0 degrees. Latitude is 0. If the body is at poles, latitude is 90 degrees. So acceleration due to gravity at equator, g minus r omega square. R is the radius of this earth, omega is the angular velocity. And g is the acceleration due to gravity at poles. It is maximum. At poles, acceleration due to gravity is maximum. Okay. Now, at a latitude phi means maybe 30 degrees, 45 degrees, 60 degrees, whatever it may be. So, at this angle, at this latitude, acceleration due to gravity formula, g minus r omega square cos square phi. In the derivation, we get that formula. We are discussing a purely entrance point of view, so formulas are required. So, at equator, formula. At a point, at any latitude, formula. At the poles, formula. 3 formulas you are getting. Now, this is a most important sentence. Even Earth spins faster or even Earth stops spinning, what happens to acceleration due to gravity at poles? So, at the poles, g value does not change. Even though irrespective of the spinning of the Earth, even though it is stopped spinning, or even though it spins faster, then at the poles the value of acceleration due to gravity does not change. It remains constant. But whereas at equator, so it reduces by some factor. That factor is r omega square. Acceleration due to gravity reduces by what factor means r omega square. So effective acceleration is g e equals to, E for equator, equals to g minus r omega square. Now, at a latitude 45 degrees we want gp. So, you have to substitute 45 degrees there. Cos square 45 is 1 by 2. Okay. So, that is g minus r omega square by 2. So, at different latitudes, we can tell acceleration due to gravity. Now, my dear students, let us go to this concept quickly. If the body feels weightlessness, as the body rotates on the surface, suppose all of a sudden, if its weight becomes 0, that is the meaning. So, if the body feels weightlessness, what happens to the acceleration due to angular velocity at equator? Angular velocity becomes under root g by r. If you substitute g value 9.8 on average, and r value 6,400 kilometers, convert into meters into 1000, then you get 0.00123 radian per second. This is also very important sentence for NEET entrance point of view. So, if the body feels weightlessness, at the equator what happens? Angular velocity becomes root g by r. So, how can you get this value? Equator formula is selected. This is equator formula. So here g value becomes 0. Weight becomes 0 means mg. You can put mg here, mr square here. So mm gets cancelled, like this. So okay, no preference to given to mass. So if the weight of the body becomes 0 at equator, so ge value becomes 0, then g minus r omega square becomes 0, then r omega square equal to g, omega square equal to g by r, omega equal to under root g by r. So this is the method. So selecting the formula is very, very important. So at equator, if the body feels weightlessness, select this formula. You put 0 here, you will get omega under root g by r. Now my next question is, at any other latitude, not only equator, at any other latitude, 45 degrees say for example, if the body feels weightlessness, if the weight of the body becomes 0 at this latitude, then you select this formula. You put phi value 45 degrees. Cos square 45 is 1 by 2. Then you substitute there. Then you will get omega equals to under root 2g by r. So root 2 times. So 0.00123 into root 2. Root 2 times increases. So this is the variation of acceleration due to gravity with the latitude. My dear students, remember carefully. So all these concepts will help you in entrance point of view. I am trying to serve you actually by giving magnificent, excellent coaching in physics. So one more important sentence we can expect this question also in entrance exam. As the body moves from equator to poles, gradually the body is moving. What happens to its weight? So small g value increases, you know. Weight means mg. Mass does not change. As the body moves from equator to poles, mass is independent factor. It is a fundamental unit, no? So it is a fundamental quantity in SI system. So mass does not change. Okay, irrespective of the position. Then acceleration due to gravity increases from equator to poles. As it increases, automatically weight of the body also increases. So very important it is. From equator to poles, weight increases, g increases, but mass remains constant. And vice versa. If it moves from poles to equator, the value changes. Opposite. Okay. So this is the information I am giving to you. Now next one, in this chapter, we can expect the most important concept, that is satellites and their energies. Now this is the earth. This is the mass of the earth. Mass of the earth it is, and radius of the earth. A body is here, mass m. Its mass is m. Now its potential energy, gravitational, I am telling now gravitational potential energy. U I am writing force into distance. Force means minus g mm by r square, gravitational force, into r gets cancelled. So potential energy minus g mm by r. My dear NEET students as well as IIT students, CBSE students, recognize this formula, gravitational potential energy. Why we are getting minus there? Because we are moving the body in this direction. Amount of work done in moving the body from the ground to this point r, distance. But gravitational force of attraction is towards center. The center of gravity towards the center. The force, gravitational force is towards the center. Against that force direction, we are going to move the body away from center through a distance r. So definitely we should do some work in overcoming the gravitational force. So in this case, we are getting minus. Force and displacement are opposite direction. So minus Fr. So minus gmm by r. So gravitational potential energy on the surface U1 minus gmm by r. Now my dear students, if the body is moved from surface to a height h, from a surface to a height h, a body is moved. What is the gravitational potential energy at that point? That is minus g mm by r plus h. Because the body is taken to a height h, so gravitational potential energy increases, no, by virtue of its position. Okay. So on the surface of the earth minus g mm by r, at a height h minus g mm by r plus h. Then question is, how much work is done in moving the satellite or any object from surface to a height h? How much work is done in moving the body? So that work done equals to how much work is done there means always final minus initial. If we do so like that, what happens? U2 minus U1. Then G mm common 1 by R1 minus 1 by R minus 1 by R plus H you will get. Because this one minus of minus, so it becomes positive, okay? So GMM common here 1 by R minus 1 by R plus H. So this is the formula for work done. Therefore, work done equals to GMM into H by R into R plus H. My dear students, listen carefully. You should recognize this formula, okay? So first formula is on the ground, gravitational potential energy. At a height, gravitational potential energy. Then work done in moving the body from ground to a height h. Very important relation. But small gm value is small gr square. Okay, capital Gm is nothing but according to the relation G equals to Gm by R square. Then Gm value gr square. If you substitute Gm value equals to G into R square, if you substitute there, then what happens? Mgr gr square, 1 rr gets cancelled. So mgr into h by r plus h. So this is also an important relation to find the work done in moving the body from ground to the height h. So mgr into h by r plus h. H value they will mention in the problem, entrance point of view. Suppose for example, 2-3 examples I am giving to you. If a body is taken to a height r by 2, what is the work done? So that implies work done equals to mgr into h value, you have to substitute r by 2. So r by 2 over r plus r by 2, 3r by 2. That is 1 by 3. You will get it. So mgr by 3, answer. Suppose when a body is taken to a height r, then what is the work done? Work done equals to same formula, mgr into r by r plus r. That is r by 2r. So instead of h you are putting r, that's all. Then 1 by 2, mgr into 1 by 2. Suppose if a body is taken to a height twice the radius. Twice the radius. Okay, no? So then what is the work done? mgr into, what happens? Tell me now. So instead of h is 2r, 2r by r plus 2r, 2r by 3. So answer is 2 by 3. So this is the method of calculating work done in moving the body from surface to a height h. Okay. Let us move to another concept quickly. Gravitational kinetic energy now. Kinetic energy formula. This is plus positive G mm by 2r. Similarly, total energy formula E equals to, so minus sum of these two, no, U plus K. U plus K, gravitational kinetic energy, K equals to. So U plus K means minus GMM by 2R. This is total energy. So gravitational kinetic, total energy. Okay. So one more important model I am giving to you. This is the surface of the earth. Mass of the earth, radius, mass. This is one of the orbit. A satellite is revolving in one orbit. Satellite number 1, S1. A satellite S is revolving in one of the orbits, which is at a height, which is having radius r plus h. Because height, this is the height from the surface, then radius of this orbit becomes r plus h. Then what is the work done in revolving this satellite, in moving the satellite, revolving satellite from one orbit to another orbit. Already satellite is revolving in one of the orbits. Now we are going to pull this satellite to another orbit, okay, in which that satellite is revolving now. So from here to here, this radius is what? What is that? This is for example, radius of this first orbit is 2r, radius of second orbit is 3r. Radius of second orbit from the center is 3r and from the center is 2r. Okay, from radius 2r to radius 3r, now the body is taken. What is the work done? That is the question. So here in this case, total energy takes place here E1 and here E2. Okay, so here to here, that is E2. E1 formula minus Gmm by 2 into 2r. R value 2r here because radius of this first orbit 2r. Okay, radius of the second orbit 3r. So minus Gmm by 2 into 3r we can write. So radius of the orbit is 3r there. So I am writing 3r. So then what is the work done? Work done equals to E2 minus E1. That's all. So E2 minus E1 means this is positive. This is positive. So Gmm common. So 1 by 4r minus 1 by 6r. This is the method, okay? So by taking LCM, 12r is LCM. Then 3 minus 2, 1 by 12r. So G capital M small m into 1 by, what is that? 1 by 12r. Okay, now? So 1 by 12, this is the answer. 1 by 12r. So 1 by 12r we can get it. So this is r square, 12r square it is. 12r means 3 minus 2, 1 by 12r. You will get it. This is the formula to find the work done. So already the satellite is revolving in one orbit. Its radius is given to r. Now we are going to project that body into another orbit of another radius 3r. Then what is the work done? So we have to consider total energies formulas. But in the first case, in the previous case, what we discussed, already the body is on the surface of the earth, not rotating, not orienting. Okay, it is on the surface of the earth. Now it is taken to a height h. That is different formula. So change in the potential energy, that is, but here change in the total energy. Because orbiting satellite it is. Orbiting satellite is taken to another orbit. So that's why total energy difference. But from surface to a height h, what is the work done? Change in the potential energies. So my dear students, this is the information in gravitation. Very, very important concepts these are. So we can expect 1 or 2 questions in NEET entrance examination from gravitation part 1 and part 2. Okay. So in the next video, class 14, we are going to project another chapter as soon as possible. Let us discuss another chapter in first year, intermediate first year. So plus 1. My dear students, if you like this video, share, subscribe and spread it to all your friends circle as soon as possible, okay, as quick as possible. If you want to listen my classes, you ring to that phone and book your seat. Okay, bye. In the next class, let us see.